Welcome everyone. Thank you for joining today's expert webinar titled AWS Lambda. I am Ria from SpringPeople. We are India's largest enterprise training provider and I will be your moderator for today's session. In today's session, we have Mr. Pankaj Dube. Mr. Pankaj stands as a distinguished figure, blending a wealth of hands-on experience with a passion for educating the next generation of cloud professionals. Boasting a stellar 5-year career as an AWS Cloud Engineer, Mr. Dube has seamlessly transitioned into a dynamic role, dedicating over 2 years to imparting invaluable cloud training. Mr. Pankaj is laser-focused expertise in AWS, including AWS Organizations, SCP, VPC, RDS, IAM, EC2, S3, CloudTrail, SQS, SNS, and the versatile Terraform. Mr. Pankaj's commitment to staying at the forefront of technology is evident in his certifications. Holding the AWS Certified Cloud Practitioner and AWS Certified Solutions Architect associate certifications attest to his foundational understanding and ability to design distributed systems on the AWS platform. In today's webinar, Pankaj will let us know about understanding overview of cloud computing models, serverless computing, AWS Serverless Portfolio, AWS Lambda, Lambda Execution, Lambda Resource Policy and Execution Roles, Lambda Invocations, use cases of Lambda, demo IT automation to stop and start EC2 instances. To all the participants, you can mention your questions in the chat box and it will be answered at the end of the session. Now, without further ado, let's start today's session. I would like to invite Mr. Pankaj to start the session. Over to you, Pankaj.
Thank you, Ria, for the quick introduction. Hello, everyone. Good evening. I hope you are able to see my screen. Okay, so a very warm welcome to all of you for this webinar today on AWS Lambda. So the agenda for today's session is we are going to see the cloud computing models followed by the serverless computing, what are the services AWS offers. We are going to go in depth of AWS Lambda, what is meant by Lambda executions, what is resource policy and executions roles, followed by networking in Lambda, what are the Lambda invocations, use cases of Lambda, and I am going to show you a demo on how to stop and start EC2 instances and few other examples with the help of Lambda. So first, to start with cloud computing models. So all of you know we have three: infrastructure as a service, platform as a service, software as a service. So if we look at this infrastructure as a service, networking, storage, servers, and virtualization is the responsibility of AWS, while the responsibility of OS, middleware, runtime, and application lies with the customer. If we check it in the platform as a service, from networking till middleware is the responsibility of AWS, while the responsibility of customer is the runtime and the application. Software as a service, from networking to applications, everything is managed by AWS. So one of the example of infrastructure as a service, EC2, Elastic Compute Cloud, example of platform as a service, AWS Lambda, and example of a software as a service, AWS Shine. So it is nothing but we have platforms like GoToWebinar, Teams, and other. So like AWS has Shine. This is a software as a service product. Now, when we talk about compute is nothing but our servers. So computing with virtual servers and serverless computing. So when we talk about computing with virtual servers, let's say you want to host an application. So first is you need the compute, you need servers. On top of that, your application is going to run, and these servers are nothing but our EC2 instances. And let's say in real time we do not we have 100 or 200 plus EC2 instances, and if I want to manage the workloads, I will use application load balancer, I can use network load balancer, I need to use the auto scaling group. So these are, I will call it as, I need to do admin overhead of managing all these things. But when we talk about serverless, AWS Lambda is the service which AWS offers as a part of serverless category. So our responsibility on this serverless is only managing the code. So in Lambda, all the servers are managed by AWS. While if you look at this EC2, all these things, all the responsibility of managing the servers, managing the patching of the EC2 instances, managing the ALB, managing the auto scaling group, setting the minimum, maximum, and desired capacity lies with you. But when a developer comes and he says like, I do not want to go into the nitty-gritty of this, so I'm just worried about my code, and I have my code and I need the infrastructure. I do not want to manage the infrastructure, I just need the infrastructure and where I can run my code. So the service which helps is the AWS Lambda. That is the reason we call it as serverless. Servers are managed by AWS. So that is the serverless computing. So what all services AWS offers as a part of serverless portfolio? Compute, AWS Lambda, AWS Fargate. Fargate is a serverless way of running containers, API proxy, API gateway, simple storage service to store unstructured data. As a part of database category, Amazon DynamoDB. It is a NoSQL database. Amazon Aurora Serverless, again a completely AWS product. Amazon Cognito for authentication. SNS for sending notification. Simple queue service where we create the queues. Orchestration as a part of orchestration, AWS step functions, analytics, Kinesis, and Athena. So these are the services which AWS offers, and we are going to discuss AWS Lambda. So AWS Lambda. So application runs on server, let's say EC2, and managing the EC2 instance is customer's responsibility. But when your application runs on Lambda, managing server is AWS responsibility. So what is Lambda? It is nothing but function as a service. We also call Lambda as a platform as a service or as a function as a service. Why function as a service? Because we create functions in AWS Lambda. And what is a function? It is nothing but a piece of code. So AWS Lambda, and in which language we can write function? So function uses a runtime. In which language? So we can write the functions Node.js, Java, Python, C#, Go, PowerShell, Ruby, and much more. So in these languages, we can write our functions. So functions are loaded and run in an runtime environment. Now let me go to the AWS console and let me show you how do we create a Lambda. So search for Lambda, run code with thinking about the servers. So servers responsibilities lies with AWS. Okay, so this is a piece of code and you can write your code in .NET, Java, Node.js, Python, Ruby, or even custom runtime. If I click on create a function, you will be able to see the supported runtime. All these are the supported runtime on AWS Lambda. So functions are loaded and run in a runtime environment. What is mean by runtime environment? I am going to show you in next 15-20 minutes. So the environment has direct memory up to 10 GB allocation. Like we have EC2 instance. EC2 instance has instance type, and instance type is nothing but blend of CPU and a memory. Like for Lambda as well, for Lambda, it has maximum amount of memory per Lambda function is 10 GB. If your application needs more than 10 GB of memory, Lambda is not for you. If your application runs within, let's say application requirement is you need memory within 10 GB, so the Lambda is best for you. So the environment has direct memory up to 10 GB and indirect CPU. What is meant by indirect CPU is, if let's say if you set 1769 MB, so you will get one virtual CPU for your function. If you double this, you will get couple of virtual CPUs. So this is mean by indirect CPUs. Function runs for up to 15 minutes. That is, we call it as the timeout. So 10 GB of memory, and what is the timeout? Is 15 minutes. Your application code should run within 15 minutes. If it is more than 15 minutes, Lambda is not for you. So these are the two important things. So 10 GB of the memory and 15-minute timeout. Function runs for up to 15 minutes, and you are built for the duration that a function runs. So very important, let's say your function run for 1 minute, you will be charged for 1 minute. This is the case in Lambda. This is the case in Lambda. But if we talk about EC2, you will have EC2 instances running even if your code runs or do not or no run. You have to pay price. You have to pay price because your EC2 instances are in running EC2 instances are in running state. Even if your application runs or do not run, you have to pay. While configuring the auto scaling group as well, for this EC2, you need to set minimum. Let's say minimum is 2 or 4. So that means even if your application is used or not used, you have kept your EC2 instance running. But in Lambda, what happens is your application, your code runs for 1 minute, you pay for 1 minute. Your code runs for 5 minutes, you pay for the number of duration. You pay for 5 minutes. So 512 MB storage available as temporary storage, and you can scale it up to 10 GB, 10240 MB. So that is the temporary storage. So next is the AWS Lambda resource policy and execution rules. Now let me quickly go to the console and let me show you where we can use Lambda. So here, if you see on my console, let me redirect to North Virginia region. Lambda is a regional service. Lambda is a regional service. So if you see here, I have couple of functions written in my AWS Lambda. One it says stop EC2, one it says start EC2. So let me redirect to the EC2 console. EC2 is nothing but virtual servers in the cloud where we can launch servers, where we can launch instances. Now, if you see here, I have 5 instances running. These are the application instances. I have 5 application servers or EC2 instances running, and the traffic on these 5 instances is between 9 AM to 6 PM, and from 6:01 PM to morning 8:59 AM there is no traffic. There is traffic in between 9 AM to 6 PM. There is traffic. That means only in between these times, for this 9 hours of time, these 5 application EC2 instances are used, and in this time zone there is no traffic. And what I need to do, I need to do a automation. What I need to automate, I need to do a stop and start of these EC2 instance. So in this 6:01 p.m., what I need to do? I need to stop my EC2. At 9 a.m., my EC2 instances should start. Why I am going to do start and stop of the EC2 instance? I want to save the cost. And this is what I am going to do with the help of Lambda functions. I am going to do with the help of Lambda function. So I have already written a code. So if you see here, 5 instances are already in running state. Now what I am going to do, I am going to this stop EC2 instance. Go to the stop EC2 instance. Okay, so this is the code. Let me again go to the dashboard. Couple of Lambda functions. Stop EC2. What is the runtime? It is Python 3.8. Python 3.8. And let me show you. Okay, so this is the Lambda function, and if you see the Lambda function, import Boto3, that is the SDK for Python. Region is US-East-1, that is nothing but North Virginia region, and I have given instances IDs. One I- all these 5 instances IDs. Let's confirm one of this AF6B. If you see here, AF6B, one of the instance. So what I am going to do, I am going to test it. So I am going to test. So if you see here, instance ID, boto3.client, region name, and what I have given action as EC2 dot stop instances. So I am going to click on test. I am going to click on test, and it says stopped your instances. Which instances are stopped? These are the 5 instances which are stopped. Let's verify and come to this screen again. So if you see here, all these instances went in stopping state. So on one click, I have written just the code to stop the EC2 instance. You might have 50 instances, you might have 100 instances. You can just mention the number of instances, write your instance IDs, and you will be able to stop your EC2 instances. Now, if you see here, we have successfully stopped EC2 instance with the help of Lambda function. Name is stop EC2. So we were discussing about the Lambda resource policy and execution rules. Now Lambda is we written a Lambda function. We have written a Lambda function, and Lambda was successfully able to start 5 EC2 instance. And when Lambda is an AWS service, EC2 is an AWS service. When we want both the service to communicate with each other, we use the role. And this role has permission. What permission? EC2 permission, EC2 full permission, and also it has a trust policy. Now let me show you the same. Okay, so I am into the IAM console, identity and access management. I am onto the roles tab, and if I show you here, role to start and stop EC2 instance. So this is a role which I have created, and what it says, allows Lambda function to call AWS services on your behalf. So this role has permission. What permission? EC2 full access. Also, I have written a customer managed policy, and also it has trust relationship. What it says is only Lambda can assume the role. So Lambda here can assume the role. This Lambda here can assume the role, and Lambda was able to perform API action. That is, it was able to do a stop of all these 5 EC2 instance. So this is the use case of role, and we call it as the execution role in Lambda. So Lambda execution roles which are attached to Lambda functions, and when a Lambda function needs to make API calls to other service, in this case EC2 instance, we use the execution roles. And one more thing we have is Lambda resource policy. So what is resource policy is what services and accounts can invoke Lambda functions, who can interact with Lambda functions, who can do what with the Lambda function, is nothing but the resource policy. And execution rules is Lambda wants to talk to EC2. Lambda wants to talk to other services. We use the IAM rule. We attach the rule. Now networking in Lambda. So by default, Lambda functions are in AWS managed VPCs. So these functions are in AWS managed VPCs. So, but if I want and they manage VPCs and they can access public AWS services and the internet. Lambda functions have no access to the VPC based services unless public IPs are provided. Now let's say here is the VPC. VPC is nothing but virtual private cloud. Your RDS instance, relational database service, resides in RDS. Let's say it is a private subnet, and Lambda wants to talk to this RDS. This is not possible, but this is possible only when Lambda resides in a VPC. So when we create a Lambda function inside a VPC, a ENI, Elastic Network Interface, is created and it is going to talk to the particular service. So that is the meaning of that we call it as. So in this case, we use VPCs in the Lambda. So by default, Lambda functions are in AWS managed VPCs and they can access public services. So, and Lambda functions have no access to VPC based services. So why I should run Lambda in a VPC? To access the resources inside the VPC. What resources? Relational database service, RDS instance. If a Lambda function inside a VPC needs access to the internet resource, we use the NAT gateway and internet gateway. So that is the networking in Lambda. So if you see here, AWS managed VPC, and these are the resources inside the VPC, EC2 or RDS. So that is the networking in Lambda. Now we have invocations. We have synchronous invocation, we have asynchronous invocation, and pool-based invocation. So what is meant by synchronous invocation? CLI or API invoke a Lambda function, passing in data and wait for a response time. Now let's say you go to a restaurant, and you place an order. You place an order to this waiter, and this waiter goes to the kitchen, and here is the cook. And you place an order, and the waiter is still here till the time the cook prepares your order and hand over it to the waiter. So waiter is still in the kitchen to observe if cook is preparing the food or not, and he is going to serve your order. So this is what we call it as synchronous invocation. Another example, again, waiter is here, you place order, he goes to the cook, and he says this is the order, 1 2 3 items, and again this waiter comes back to take order from other customers, and here is your order with the cook. That is, we call it as asynchronous invocation. So if we relate it to Lambda, so Lambda function responds with data or failure. So now if you see here, I did try to stop EC2 instances. This is what we call it as the synchronous invocation. I ran the code in the stop EC2 instance. I have ran this code in the stop EC2 instance and I got the response. In the same way, let me now show you how to start the EC2 instance. If you see here, all the EC2 instances application servers are stopped. Now I want to start. So let me try to start it now. Again, import Boto3 region instance IDs, and here I have EC2.start instances. If I click on test, it says started your EC2 instances. Let's verify if the instances are started. Okay, it is in pending state. Couple of minutes, it will come in running state. So I was successfully able to start my EC2 instances. So this is a synchronous invocation. So errors or retries have to be handled with the client. In case if I got an error, let's say if the code was not running, it is my responsibility to look into the code and fix it. So this is the synchronous invocation. And when we talk about asynchronous invocation, used when AWS services invoke Lambda function. What are the examples? Lambda can be triggered when objects are created or deleted in S3. Lambda functions can be connected to SQS queue, simple queue service, responding to the messages. Let's say if there is a change in DynamoDB table, inserts, updates, or delete, we can trigger Lambda function and get notified there are inserts, updates, or deletes. And compared to synchronous, asynchronous invocation is more efficient due to reduced waiting time. So this is about the synchronous and asynchronous invocation. We also have pool-based invocation. So AWS Lambda can process and respond to streaming data from Kinesis streams. So example of the service which supports pool-based invocation is Amazon Kinesis, Amazon SQS, and DynamoDB streams. So that is about the invocation. Now next is the important part, Lambda concurrency. So what is meant by concurrency? So it is the number of in-flight requests that your Lambda function is handling at the same time. So if I go to the Lambda function again, if I go to the dashboard and if I click on AWS, if you see here, full account concurrency. So at a given time in North Virginia region, 100 concurrency units are present to run the request. So only 100. Even if you have 10 functions, there will be only 100 concurrency units to run your function. So this is the number of in-flight requests that your AWS Lambda function is handling at the same time. So for each concurrent request, Lambda provisions a separate instance. I am going to talk about it. So default of 1000 units of concurrency. Here if you see, it is 100. If I go to Mumbai region, it is 10. If I want to increase this full account concurrency, I need to go to the service quotas. And I need to search for AWS Lambda, view the quotas, and what I need to do, I need to request increase at account level. Let's say I want to place it as 1000 and request. It says quota increase requested for concurrent execution. This is what I have done in Mumbai because there were only 10 concurrency units in the Lambda in Mumbai region. Now if I want to redirect to Mumbai region because I have 100 full account concurrency. So what is meant by concurrency is the number of in-flight requests that your Lambda function is handling. Okay, now if I show you here, let me close this. My EC2 instances are in running state. I have couple of Lambda functions, and let's talk about the concurrency. Again, I'm going to stop EC2 instance. And click on test. Okay, click on test. Let me take a screenshot of this. Okay, so now if you talk about the billing, so the function is we have ran the stop EC2 duration for which the function ran 791.07 millisecond. Build duration, I am going to get the bill for 792 millisecond. Maximum memory size is 128 MB memory assigned to the function. How much did the function use? 84 MB. And this is the init duration. 542.56 millisecond. Now what is mean by this init duration is Lambda. So if you read here, for each concurrent request, Lambda provisions a separate instance of your execution environment. So what is mean by this init is, I will explain you again because I want to start the EC2 instance and stop it. So you will see the difference. So as of now, my instances are in stop state. Again, I am going to start it. I am going to test it, and I am going to start the EC2 instance. If you see here, my instances are in pending state. The Lambda ran, and even here as well, if you see, duration is 1043. You are charged for 1044 milliseconds. Maximum memory used was 84, and here the init duration is 522.49. Okay, my instances are running state. Great. Again, I am going to the same stop EC2 instance. Going to the stop EC2 instance, go to the Lambda function. Again, I am going to test it. Okay, I'm going to test it, and let me take a screenshot of this now. Now, if you see here, so the first time I ran my function, first time I ran the stop EC2 instance, and this is the second time I ran the stop EC2 function. So if you see here, I got the build duration is 792 millisecond. The build duration is 711 millisecond. Memory used was okay 84 MB, but here there is no init in the second stop EC2 instances. So this is what we mean by execution environment, and we also call it as warm start. This is what we call it as the warm start, and this is what we call it as the cold start. So again, we have different things. Concurrency I am going to discuss. So what is mean by instance? So provides a separate instance of your execution environment. So what is mean by execution environment is you have written a code to stop the EC2 instances. Okay, and you have specified, let's say, 128 of memory to your Lambda function. Whenever you run this stop EC2, what will happen is a single piece of hardware is allocated, and you have defined 128 memory. Let's say 128 memory, 128 MB memory is assigned. You have selected Python 3.8 as the runtime. It gets installed on this hardware, and on top of that, your code runs. What code runs? This code for stop EC2 instance runs. This is what we call it as the execution environment. This is what we call it as the execution environment. So Lambda provides separate instance of your execution environment, and default behavior is unreserved concurrency, and default of 1000 units of concurrency. If exceeds max invocations are throttled. So at a time, 1000 units of concurrency or Lambda request can run. If it goes above 1000, your function, the max invocations are throttled. You will get an error. So next, talk about the reserved concurrency, and we have provisioned concurrency. We have provisioned concurrency. First is, we'll talk about reserved concurrency. What is reserved concurrency? Maximum number of concurrent units allocated to your function. So now if you see here in the Lambda in North Virginia region, how much is full account concurrency is 100, out of which, now let's say in my environment I have 4 functions, 1, 2, 3, and 4. Fourth one is very critical function, and I can run 100 concurrency unit, because this is the limit in the North Virginia region. If I want, I can increase it. So what I need is this fourth function should not get throttled. So in this case, what I am going to do is I am going to reserve the concurrency. I'm going to use reserved concurrency. So what I am going to do, out of this 100, I will assign 50 concurrency units to this fourth function. So even if this fourth function runs or not runs, 50 concurrency units will be reserved, and 100 minus 50 is 50, and these 3 functions will use this remaining concurrency units. So that is the reserved concurrency. So when a function has reserved concurrency units, no other function can use that concurrency unit. So for fourth function, you have reserved 50 units. Okay, you have reserved 50 units. These 50 units only will be available when fourth number function runs. Other 3 units can use other rest of the 50 concurrency units. So that is the reserved concurrency. So you can reserve certain number of concurrency units for your critical functions. So reserving 500 out of 1000. So configuring reserved concurrency incurs no additional charge. So there are no additional charge. So this is about the reserved concurrency. And we'll next talk about the Lambda execution. So before I discuss provision concurrency, there are a couple of concepts. Lambda execution environment. So what happens in the execution environment? I explained you. A single piece of hardware is allocated to your function. Single piece of hardware is allocated. On top of that, memory is assigned, your runtime is installed, and your code for stop or start runs. So this is the execution environment. So what are the phases? Init phase, invoke phase, and shutdown phase. So what is the init phase? Creates the execution environment. Let me, okay, so this is the init duration. Init duration, if you see 542.56, this was the time taken to create that execution environment. So that is meant by init phase. Invoke phase runs the function handler, that is the cold start. Next invoke is warm start, same environment, and shutdown is the terminate the environment. So here if you see, couple of important terms is cold start and warm start. So first time our function ran and it created the execution environment, and this is what I refer to as the cold start. And second time it ran the stop ec2 function on the environment same environment. This is what we call it as warm start. So now if I go to the next slide, it says cold start. What is cold start? New execution environment is created every time for that function. And when we talk about warm start, same execution context. Same execution context is nothing but the same hardware which has 128 memory and which has Python 3.8 runtime install. Same instance, same environment was used when I ran the second time stop EC2 instance. So that is the meaning of warm start. So same execution context is reused, new event is passed, but the execution context creation can be skipped. So a Lambda invocation can reuse an execution environment. So that is about the execution environment. And now let's talk about the provisioned concurrency. So AWS, what is provisioned concurrency? AWS will create and keep number of contexts warm and ready to use, which will help to improve the start speed. Means I do not want to waste the time on this init duration. And that's the reason I am going to keep my functions warm. So this is how we can, this can be achieved only in the provisioned concurrency. So what it says, number of pre-initialized and execution environment allocated to your function. So it eliminates cold start. So if you see here, second time it didn't give in the when the function ran, it didn't say init duration, and that's the meaning of eliminates cold start and decrease latency. Why should I use provision concurrency? Is to decrease the latency so that my application can run faster. So we can set up the auto scaling for provision concurrency. And if you see here, configuring provision concurrency includes additional charges. Why additional charges? Because if you read here, number of pre-initialized execution environments, you are keeping the execution environment execution environment ready for your function. So let's say, assume this is what you are trying to keep ready. So let's say here is your Lambda function, and you do not want to waste the time allocating hardware and memory and the runtime installed on that particular environment. You are keeping the execution environment ready for your function to decrease the latency. So this is the use case where you use AWS Lambda. So it eliminates cold start and decrease the latency. Now next is logging in Lambda. So Lambda uses CloudWatch logs for logging and logs from the Lambda execution. Now if I go to the CloudWatch, what is CloudWatch? It is used to monitor resources and application in AWS. Okay, let me show it to you from here first. So go to your functions, go to stop EC2, and if click on the monitor, and if you see here, how much time did you execute the function? So if you see here, at this time you have invoked one time. This is the duration, how much your function ran, error count and success rate, total concurrent execution. These are the metrics related to AWS Lambda. Now if I click on view CloudWatch logs, okay, so CloudWatch logs for stop EC2 Lambda function, and first is the log streams, and what last event time 5:35. Click on that, and if you see here, init start runtime Python 3.8. After that, 50035 the start request ID, and 5035 it stopped your instances. Again, there was a request to stop your instances. So this is how you can see the CloudWatch logs for the AWS Lambda. So Lambda metrics such as invocation success or invocation failure retries are stored in CloudWatch. So if these are the logs, so log groups, this is the Lambda function stop EC2, inside which you have log streams, and inside the log streams you have the log groups. So this function we ran at 5 p.m., we ran at 4:47 p.m., and this is what CloudWatch has captured. There was stop, again we ran the stop function to stop the instances. This is what it shows. So Lambda and IAM execution roles. So again, Lambda needs permission if the logs needs to be captured in the CloudWatch. So this is again possible with the help of IAM role, execution role. Now what is the pricing for Lambda? So you are charged based on number of requests for your function, and you are charged for the compute time used. So you are charged for the compute time. What is the compute time? This is the time you will be charged for. Request pricing, 1 million requests per month are free. Now let me go to the console again, and let me go to the Python. Let me try to run. So, okay, so one of the use case, let's say this is camera and I am trying to upload the data in S3 buckets. So number of requests, you will get price as per the number of requests. Okay, streaming analytics or from mobile or mobile IoT backends. Now if I click on scale seamlessly, if you see here invocations, it is 66,000, 1,59,000, 255, 316, 396, 5 lakhs, 6 lakhs. Cost is 0. 7 lakhs cost is 0. 738 cost is 0. 869 cost is 0. Now once it goes above 1 million, you will get price. You will be get charged for this. So if you see here, for first 1 million request, it is free. For first 1 million request, it is free, and first 400k GB per second is free. So what is mean by, so if you see here on the slide, first 1 million requests per month are free, and next request you will be charged for $0.20 per 1 million request. Okay. Next is the duration pricing. So if you see here duration pricing, 4 lakh GB seconds. So if you see here 4 4 lakhs seconds. If I divide it by 60, I will get into minutes. If I divide by 60, I will get into hours. And if you calculate, this is nearly equal to 110 hours of compute time you get free. So this is about Lambda pricing. So use cases of Lambda: web application, backends, data processing, chatbots, Amazon Alexa, and IT automation. We saw how to do a stop and start of the EC2 instance. Another use case of IT automation is, let's say, EC2 instances, and I want to trigger the AMIs. I want to create an AMIs. I want to automate it. So again, I can write Lambda functions to create the EC2, you create the AMIs out of this EC2 instances. So these are the use cases of AWS Lambda, and that was all about the AWS Lambda.
All right. Thank you so much, Pankaj, for your invaluable. Am I audible?
Yeah, you are audible.
Okay. Thank you, Pankaj, for your invaluable insights on technology. I'm sure it was certainly a very informative session for all of you. If you guys are interested in learning more about various AWS, do check out our super discounted batches of virtual instructor LED trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we'd be happy to discuss and schedule private batches for you. If you don't have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call on our number displayed on the current slide. Now we will open the forum to answer questions that we have received during the session. Over to you, Pankaj.
Okay. So please let me know if you have any questions. Okay, Ria. I don't think there are any questions to answer.
We're waiting for them to answer the poll questions also. All right, thank you everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants soon. I request you to kindly provide feedback before signing off, which will help us improve the quality of our future events. Thanks again for joining us today. Signing off on the behalf of Spring People team. Hope to see you again for our next expert webinar. Thank you.